Water is practically everywhere on Earth. Viewed from space, one of the most striking features of our home planet is water, in both liquid and frozen forms, that covers approximately 70% of the Earth's surface. Water is the only common substance that can exist naturally as gas, liquid, or solid at a relatively small range of temperatures and pressures. At standard pressure, water freezes at 0 degrees Celsius and becomes water vapor at 100 degrees Celsius. When pressure changes, the boiling or freezing temperature of water also shifts. Therefore, sometimes all three states are even present at the same time and place. One of the best examples would be the eruption of a geyser in Yellowstone National Park in wintertime. Now, let's explore how it's formed. Water heated on the ground that rises through a crack to the surface creates a hot spring. Geysers are hot springs with constrictions in their passageway that prevent water from circulating freely to the surface where heat would escape. At this time, its boiling point can exceed 100 degrees Celsius because the pressure on the ground is higher than the surface. Due to heating, steam forms and expands as water rises. In wintertime, when temperature is way below 0 degrees Celsius, as the superheated water gets into contact with the cold air, ice crystals are formed. Therefore, you can see water in gas, liquid, and solid state all at once. In all, the Earth's water content is about 1.39 billion cubic kilometers, with the bulk of it, about 96.5%, being in the global oceans. As for the rest, approximately 1.7% is stored in the polar ice caps, glaciers, and permanent snow. And another 1.7% is stored in groundwater, lakes, rivers, streams, and soil. Only a thousandth of the total water on Earth exists as water vapor in the atmosphere. Earth's water is always in movement, and the natural water cycle, also known as the hydrological cycle, describes the continuous movement of water between the oceans, the atmosphere, the land, and living organisms. Like other biogeochemical cycles, the water cycle has no beginning or end. But we will begin with the oceans, since that is where most of Earth's water exists. The sun, which drives the water cycle, heats water in the oceans. Some of it evaporates as vapor into the air. Ice and snow can sublimate directly into water vapor. Rising air currents takes the vapor up into the atmosphere along with water from evapotranspiration, which refers to water transpired from plants and evaporated from the soil. The vapor rises into air where cooler temperatures cause it to condense into clouds. While air currents move clouds around the globe, cloud particles collide, roll, and fall out of the sky as precipitation. Some precipitation falls as snow and can be accumulated as ice caps and glaciers, which can store frozen water for thousands of years. Snowpacks in warmer climates often thaw and melt when spring arrives, and the melted water flows overland as snow melt. Most precipitation falls back into the ocean or onto land, where, due to gravity, the precipitation flows over the ground as surface runoff. A portion of runoff enters rivers and valleys in the landscape, with stream flow moving water towards the oceans. Runoff and groundwater seepage accumulate and are stored as freshwater in lakes. Not all runoff flows into rivers, though. Much of it soaks into the ground as infiltration or percolation. Some water infiltrates deep into the ground and replenishes aquifers, which store huge amounts of fresh water for long periods of time. Some infiltration stays close to land surface and can seep back into surface water bodies as groundwater discharge and some groundwater finds opening in the land surface and emerged as freshwater springs. Also, groundwater can move into plants and evaporate from plants into the atmosphere. Over time, though, all of this water keeps moving, with some re-entering the ocean, where the water cycle begins. This is the entire journey of the water cycle. Okay, let's go over the key processes in water cycle once more. Evaporation occurs when water on Earth's surface changes to water vapor. Sublimation occurs when ice and snow change directly to water vapor without first melting into liquid water. Transpiration occurs when plants release water vapor through leaf pores. Condensation is the process in which water vapor changes to liquid water, forming water droplets. If enough water droplets are present, they may form a visible cloud. Precipitation is that water droplets become large enough that fall to Earth because of gravity as rain, snow, sleet, or hail. Precipitation that falls on land may flow over the surface of the ground. This water is called runoff. Infiltration is the process by which water on the ground surface enters the soil. Percolation happens at deeper depths when water moves vertically to join water table, usually slower compared to infiltration. Groundwater is the water found underground in the cracks and space in soil, sand, and rock. It is stored in and moves slowly through geological formations of soil, sand, and rocks called aquifers. Finally, how important is the water cycle to our environment? The water cycle impacts ecosystems, economies, and our daily lives. The water cycle enables the availability of water in our daily life, such as drinking, industrial applications, irrigating agriculture, hydropower, waste disposal, and recreation. Through a series of evaporation, transpiration, condensation, precipitation, infiltration, runoff, and other small processes, the water cycle keeps the Earth's water clean, distributes the water across the planet's surface, maintains aquatic ecosystem, and aids in the process of plant growth. If water didn't naturally recycle itself, we would run out of clean water. So it is important that water sources are protected both for human uses and ecosystem health. Okay, that will be all for today's lesson.